So let's look at a demo. This is what the example white balance routine looks like in Matlab. As you can see, it's quite short. Matlab is a high-level programming language. It's got a simple syntax and a whole lot of built-in math and engineering functions. So this whole routine can be written in just 6 lines of code. Now, the way this is written now, currently this function runs entirely on the CPU. And so next what we're going to do is use the Matlab profiler to identify sections of this code that might be candidates to run on the GPU to improve performance. So we run the profiler, and it indicates that this last line is by far the most time-consuming. This line of code is applying an operation to each color channel across every pixel in the image. Such an operation could be sped up when executed on a GPU. This is clearly a good candidate for parallel computing. So before using the GPU, let's first measure how long it takes to execute the white balance function on the CPU using the tick and tock commands. Notice that it takes approximately 0.124 seconds to execute the code entirely on the CPU. Now, to utilize the GPU for executing that last line of code, there's a couple of options. One thing that we could do is simply transfer the image data to the GPU memory using the GPU array command, and that's what we're doing here on line 14 of this slightly modified white balance routine. Whenever a GPU is passed as input to the most common core MATLAB functions, as in this last line of code, then those computations will automatically be executed on the GPU. So here, by adding just that single line of code, notice that the time it takes to execute the white balance function went down from 0.124 seconds to 0.026 seconds. So that's a big speed up, especially for a single line of code. So the second approach to using the GPU for computing within MATLAB is to use the MATLAB interface to invoke custom CUDA kernels. Here's a CUDA kernel that performs the same operation that was causing that original bottleneck in the white balance routine. And in this MATLAB function, that CUDA kernel is being used to speed up the execution time instead of using GPU array. So the first 12 lines of code are the same as in the original white balance routine. Then, however, MATLAB loads the kernel and sets up the threading parameters, creates data on the GPU, and finally invokes the kernel using feval. And now notice that the white balance routine executes in 0.022 seconds using the CUDA kernel. So the application executes faster, but we should still verify that our CUDA code does what it's supposed to do. So we need to ask the question, do the results from the GPU match the results that we were getting on the CPU? And you can check that the outputs match using this simple script, which computes the norm of the difference between outputs. So a norm equal to 0 signifies that the two outputs are the same. After running the verify script, we can see that the two outputs are the same, and there we go. So in summary, MATLAB is a nice high-level language. It's used heavily by scientists and engineers all over the world for all kinds of applications, and it's a great way to quickly design and test algorithms that perform computations on a GPU, either by using the GPU array command or by using an interface directly to CUDA kernels. Furthermore, existing CUDA kernels can be quickly and easily tested inside MATLAB. It makes a great harness for developing and exploring and testing CUDA kernels. And that's MATLAB.